Good morning, everyone. So today we're going to start our first distance lesson. We're going to be continuing with multiplication and division equations. So this is the second lesson with that. We started it out with GoMath, and now we're going to be doing the Ready lesson that follows, and that would be lesson 19. I'm going to attempt to do this lesson by showing you the PDF version and writing along, so that hopefully you can follow along a little easier. I do also have a whiteboard at home, and I will try out the next lesson using that. And then what I'd like for you guys to do is tell me which way you prefer. Could even do a combination of both going forward. So I do need some feedback from you guys, okay? So let me know in the comments on the Google Classroom. My YouTube account will not allow you guys to comment anymore because I did have to state that it is a channel that's meant for children, since you guys are my students. And so it has disabled all the comments. There's like a new YouTube agreement where you have to say if your YouTube is meant for children, and in that case they do disable the comments just to protect you guys, which I think is actually awesome. So that being said, if you would like to print out this PDF, it's attached on the daily agenda and you can follow along with me. Now again, this is just the exact same thing that I use on the smartboard. It was already made because I had everything planned in advance. Now it's just a matter of getting this all set up, distance learning for you guys. Okay, so this is how we're going to do it today, and let me know how you like it, and we'll try the whiteboard next, and then we'll see what works. Okay guys, so let's get started. Okay guys, so we're going to start out, we're in the GoMath book. This is lesson 19. I am not sure what page it is, but I'm sure Journey will tell you all in the comments. This lesson is about solving multiplication equations, which we've done already, and this is the Ready version. So we're going to start off by looking at the picture. So let's read this problem below, and then we're going to look at this model here to visualize. Delia put 2 bags of blocks in the left side of a pan balance. That's here. Each bag has the same number of blocks. So in this bag, the amount of blocks that's in them is exactly the same. After she adds 10 blocks to the right side of the pans now hang evenly. So our job is to figure out how many blocks are in one of these bags. Okay, so remember, as we did this in the adding and subtracting equations, looking at that visual can really give you a good idea. So we know that there's 10 here on this side, and there's the same amount of blocks in each one of these bags, then we can kind of figure out, just by thinking about it, that there must be 5 in each bag, if it's even, right? So the 2 bags together have a total of 10 blocks, like we said. So just by looking and thinking about it, we can figure out that there would be 5 in each bag. So now we're going to move on to the actually solving part. So this is where we're writing expressions and then eventually setting up an equation. To represent the number of blocks in the left side of the pan, we have 2 x's there, right? One bag had x and the other bag had x. So together that's 2x, right? So remember that when we see a coefficient and a variable together, that's 2x, that means that this is 2 times x. That's always going to be multiplication. And on the right side of your pan, or balance, whatever we're calling it, the number of blocks is 10. So since the pans are hanging evenly, we know that there's the same number of blocks in each pan. So to write the equation, which is of course already written for us, we're taking the number of blocks that were on the left, that was 2 times x, and that's equal to 10. And now we know how to solve this, but let's move on. So we're going to do our connect to everyone's favorite. So we're going to use the inverse operations to solve the problem. If you go back to the solve it on the previous page, what did we need to do in order to find the blocks in one bag? What did we need to do? We basically divided 10 by 2, just by thinking about it, right? I'll go back to the picture. We knew there was 10 here. We knew there were 2 bags, and each bag had to have the same amount. So we took the 10 and we just divided it by 2 in our heads. We knew there would be 5 in each bag. So the expression 2x is a multiplication expression. It tells you to combine 2 equal groups of x blocks each. What's the opposite of combining 2 equal group of blocks? That would be dividing. Right? One operation is the inverse of multiplication. Same thing, right? Division. Miss Morano can't spell today. I'm trying to focus so much on holding this. I can't think about how to spell. How can we isolate the variable in 2x equals 10? Well, what do? We always do the inverse operation, which is why we just stated that above. So in order to isolate it, remember what we do is we look at the variable, we ask ourselves what's actually happening to the variable. In this case, we're multiplying by 2. So to isolate it, we're going to undo that. So we would divide, and this time we're going to be specific, by 2. Okay? Number 15, when you isolate the variable, what must you do to balance the equation? Well, I'm going to have you right here what I've been saying and drilling into your heads for the past week. What you do to one side, you must do to the other. Let's put it in quotes. So that means I'm going to divide by 2 on the other side of the equation as well. Okay, so now we're going to fill in the blanks here basically. So the only difference between what I've been doing is I like to draw that line in between the equation to separate so we can see what side is which. And that's just because in the future our algebra equations are going to get way more complicated. And in order to do the quote-unquote same thing to both sides, we're going to need to really know which side is which. So first I look here. I'm asking myself what's happening to the variable. It's being multiplied by 2. So to undo that, we divide by 2. And remember, we're super cool algebra kids now. So we don't use that division symbol anymore. Now we use a fraction. And what I do to one side, I must do to the other side. So I divide the 10 by 2 as well. Remember that the 2's cancel out. Bye. The reason why, of course, is because 2 divided by 2 is 1. 1 times x is just x. That's why it goes away. And then, of course, 10 divided by 2 is 5. So, as we predicted, there are 5 blocks in each bag. How could we check our solution? I can hear you all singing right now. Plug it in, plug it in, plug it in, and check it. If it's equal, then you've done it right. So we're going to just take one little second here to check it ourselves. So, to remind you, you set up your check, you actually label it, you rewrite your original equation, 2x equals 10, and then you plug in your answer. So if you got x equals 5, you're replacing, anywhere you see an x, you're replacing it with 5 to check. Remember, when you have a coefficient and a variable together, you really need to write those parentheses so that you remember that this is multiplication. If we don't write the parentheses there, we're going to have 25 equals 10, and we know that's not right. 2 times 5, that gives me 10. 10 equals 10, which is what I want, and I know I did it right. So your answer is x equals 5. Okay, to finish off today, we're going to do one last question. We're going to do the try it, and I'm going to walk you through the steps one more time. This time we're not going through all of those fill in the blanks. So we're going to solve 7x equals 21. So you know I always like to rewrite our problem like this. 7x equals 21. First thing we do is separate the two sides of the equation. Now I'm looking at the side with the variable, and I'm asking myself, what is happening to x? The operation that's happening to x is that it's being multiplied by 7, right? We just write this off to the side if you have trouble identifying your inverse operation so that you can really see what you're doing the opposite of. So if I'm multiplying by 7, I need to do the inverse of that, which would be dividing by 7. Sorry, got it all in focus there. So I divide by 7 on both sides. This cancels out right away. What I do to one side, I do to the other. So x is still here because 7 divided by 7 is 1. X is equal to 21 divided by 7 is 3. So x is equal to 3. And we're going to check our answer. Now, of course, as we've been saying all along, we know we can figure this out from the very beginning because we know 7 times 3 is 21. But we're learning this process fully so that when we have crazy complicated equations, we're going to know exactly what steps to follow. So again, to check, we rewrite our equation. We write our answer, which was x equals 3, and we're going to replace everywhere we see an x. We're going to plug in the 3 to make sure we got this right. So this becomes 7 times 3, remember those parentheses, is equal to 21. 21 equals 21. I know you're all thinking of Mateo right now. And we know we're right. Okay? Now, if you check your daily agenda, you'll see that your practice for today is to complete the practice worksheet. Now, I've posted it on Google Classroom on the stream. It's the daily agenda. It's got all the information. It's got this PDF. It's got the practice worksheet, which is going to be for practice and the quote-unquote homework. And it's also got a whole bunch of links in case you're still confused. One thing I really quickly wanted to go over, because I just realized it's in the worksheet, is an example when you have a fraction. So we had division examples, right? So let's say we had x divided by 2 is equal to 10. We do the same thing. We still identify what's happening. In this case, x is being divided by 2. Okay, so when we do our opposite, we're going to be multiplying by 2 because that's the opposite of dividing by 2. So remember, super cool algebra kids, we're not using the x for multiplication anymore. Even if GoMath still uses it, we don't use it anymore. Okay, and we need it up here in the numerator. So this cancels out because 2 divided by 2 is 1. And what you do to one side, you have to do to the other side. So that would give us x equals 20. Now, that being said, what happens if we have an actual fraction in front of a variable? For example, 1/2 x equals 10. Technically, these are exactly the same. X divided by 2 is the same as 1/2 of x, right? Do we all agree? Yes? So the question here is now, instead of writing dividing by 2, what you're really doing is multiplying by 1/2. So then we have to deal with a fraction. Hopefully we all remember that when you divide by a fraction, what you're really doing is multiplying by its reciprocal, right? So what we're really going to do when you have a fraction in front of the variable is you're just going to multiply by the reciprocal on both sides. And that's because of good old keep, change, flip, right? So we're going to multiply by 2 over 1 or just 2, okay? And that cancels out. And then you do it to the other side as well. You don't really need to write over 1, but I'll leave it up to you. And then, of course, this is x equals 20. We still get the same thing. I do believe that there's a few of these on your worksheets. I wanted to make sure you saw what it looked like, okay? When in doubt, don't go through the whole keep, change, flip process here. Just skip to the multiplying by the reciprocal part. All right, guys? I hope that was helpful. Have fun.